Dexterous hummingbirds can flap their wings up to 5,000 times a minute to create their signature drumming noise. This skill means that up to 30% of their body weight is made of flight muscle, while for most birds it is around just 15%. This abundance of strength makes them excellent flyers, and now researchers have found that even the largest of the hummingbirds are as skilled at flight as the tiniest ones. Study co-lead author Dr Roslyn Dakin of the University of British Columbia in Canada said, "Studies of bats, birds and other animals show that increases in body mass can have a detrimental effect on many aspects of flight. But with hummingbirds, the correlated evolution of increased wing size and muscle mass helps larger species compensate for their greater body masses." Dr Dakin, study co-lead Dr Paolo Segre and Professor Douglas Altshuler used high-speed video cameras to determine how maneuverability relates to differences in body shapes and sizes. They found that acceleration is primarily driven by a bird's muscle capacity, whereas maneuvers involving rotations are driven primarily by wing size, but skill also plays a role. Professor Altshuler said, "The hummingbirds tend to play to their strengths, especially with complex moves. For example, species that have the ability to power through turns tend to use more arcing trajectories, and they shy away from performing turns in which they decelerate to turn on a dime." In a recent study, researchers at the University of Connecticut studied 18 hummingbird species from 7 of the 9 hummingbird groups throughout North and South America. Nectar is drawn into the tongue by the elastic expansion of the grooves after they are squeezed flat by the beak. While the unusual tongue structure is collapsed when the tongue crosses the space between the bill tip and the nectar pool of a flower. But once it contacts the nectar surface, the supply of fluid allows the collapsed groove to gradually recover to a relaxed cylindrical shape as the nectar fills it. The bird then squeezes nectar from its tongue by collapsing the grooves and loading elastic energy into the groove walls. The action also enables the bird to pump more nectar, creating a fast repeating action. Researchers have found that hummingbirds process visual information in a different way to other animals. Rather than judging how objects move across their field of vision, like humans and other animals, the tiny birds judge objects by how close or far away they seem. Objects growing larger are perceived as coming towards the birds, while those shrinking are processed as moving away. The Canadian scientists believe relying on this approach enables them to carry out their lightning-quick maneuvers without crashing. The shining sunbeam, Agiliactis cuperpennis, is found at high altitudes, often in mountain ranges. Smaller hummingbirds may turn sharper in flight, but larger species have more powerful wings. The number of times a hummingbird's wing speed is different from one species to another and ranges from 720 to 5,400 times per minute when hovering. Hummingbirds are also the only birds that can fly backwards thanks to their flexible wing joints, and some hummingbirds fly at speeds greater than 33 miles per hour. Because there is so much muscle to power when in flight, aerobic respiration for the muscles requires a large heart to provide a constant supply of oxygen via the blood. As a result, a hummingbird's heart is relatively the largest of all animals at 2.5% of its body weight. Due to the huge energy requirements, hummingbirds eat up to twice their body weight in food every day and spend most of their time, when they're not flying, resting on twigs. They won't be found walking, though, as they have very small and weak feet. The researchers captured more than 200 individual hummingbirds from 25 Central and South American species. Computer vision technology developed by co-author Andrew Straw at the University of Freiburg in Germany enabled the researchers to record in-flight maneuvers with precision. Dr. Segre, now at Stanford University in California, said, "We recorded over 330,000 maneuvers, including many repeated maneuvers for each bird." Capturing that much data was a challenge. Our first field site was at a biological reserve deep in the Peruvian Amazon, an area with many species of hummingbirds, but only accessible by boat. We ran our computers and cameras using solar panels and generators in a thatched hut with strategically placed rain buckets. Hummingbirds vary greatly in body mass and wing shape, and many species have evolved to perform at high elevation, where the air density is low. Dr. Dakin said that variety offers researchers a great opportunity to study how traits relate to agility in flight. She added, "There are a lot of questions we can look into now, such as how do these differences impact their ability to survive and find mates? If maneuverability is an advantage to some species, how do others get by with less agility? What is it about their lifestyle that differs?" The research was published in the journal Science.